Anything in this code look interesting as a JS dev? Honestly, most of it should. I've never seen JS code like this. It looks more like something like Rust, but this is real JavaScript. At the very least, this is a real JavaScript proposal, and there are some people who are quite excited about it, including, of course, Jared Sumner, the creator of Bun. What is going on here, though? Is this real, or is this some pile of hacks in Bun? This is very real. This is so real that the standard for it, the structs proposal, has just made it to stage 2. It only says stage 1 here, but it did just advance. And I am very excited to talk all about how structs could theoretically make JavaScript a really, really fast language. Speaking of really fast, let's quickly hear a word from today's sponsor.
Huh? That's not good. What did you do? Google login is broken entirely right now. Apparently our design wasn't compliant with Google's policies. The grayscale logo that we were using caused our auth to get locked out entirely. Why not use Clerk? Huh? Since when does the Linux guy recommend using a service to solve the problem? Oh, that's my exception. When it breaks, it sucks. And that's coming from somebody whose audio doesn't work right now. Getting auth working is easy. Dealing with multi-factor, SSO, magic links, and all the things you have to deal with mobile, it's just not worth it. Thank you, Clerk, for sponsoring today's video.
Let's dive in. I want to start with this example that Jared gave us. This will make JavaScript competitive with Go and Rust at concurrency. So here is the example. We have the shared struct counter, value 0. Counter is a new counter. It allocates. We have an assert throw, so just make sure that it throws. When we try to do these things, we can't write or read to the shared memory. But if we write unsafe around it, then we can actually call this. But if we want to increment it properly, we can make a lock with atomics.mutex.lock, a given mutex, and then increase the counter's value. Very, very interesting. The problem today is that everything goes through post message. There's no shared memory outside of the shared array buffer, which is so difficult to use in practice. Not only is post message serialization slow, it's also bound by the event loop. Microtasks and tasks get executed first. Very important. If you try to isolate your state in a way where you can change it in multiple places, you have to do that changing through messages, which always clone memory and get deprioritized. So this would allow us to directly update values without having to copy them all over the place or make things with our own event and messaging system. This will allow us to have mutatable values that exist in a shared state across things without constantly having to copy, read, write, and deal with all of those additional layers. So we get the memory safety and that isolation. Languages like Go and Rust and Zig don't prevent you from reading data from other threads immediately each time. You don't always have to clone everything. You can just read stuff. The rules for doing that are complicated, but you can. And JavaScript should let you do that too. Very, very interesting stuff. And to be clear, the goal of a proposal like this isn't to give people code that every dev is going to write. I would imagine the vast majority of the people who are watching this video are application developers, and y'all aren't going to be writing code like this. But if you are building a really complex like WebAssembly library or some deep tooling around canvases that requires a ton of things to transform constantly, or you're Paul Henschel building React 3 Fiber, those people can benefit a ton from this and expose it as libraries that we just call like normal JS and don't even think about it. The idea of having an unsafe wrapper like this, like a straight up closure that says unsafe in JS, is so funny when you consider the fact that most JS code is already unsafe. But yeah, very exciting stuff. Let's read through this proposal to do our best to understand why people are so excited. The proposal introduces 4 logical features: structs, or unshared structs, which are fixed layout objects. They behave like class instances with more restrictions that are beneficial for optimization and analysis. This is the key piece here. If you have an object or even a class in JavaScript, it's possible to just like, how do I put it? You can just add and remove keys kind of willy-nilly. It's kind of crazy that you can have an object that you want locked down to these specific keys, and you just add new keys as you want trivially, which can break a ton of things, especially if you're not checking to see those other keys exist or not. Oof. And don't start with object.freeze. No one actually uses that shit. And it's barely what we're looking for here. Because every object could have new keys added whenever, the way that the memory is allocated for that is a bit chaotic because we have to assume that object can change its shape entirely at any point. But with a struct, we're specifying, no, this is the structure of this object. That's what the fixed layout part means. It means this will not change. It will always have these keys that are these types, which means it's much easier to optimize in terms of memory. There are also shared structs, which are further restricted structs that can be shared and accessed in parallel by multiple agents. They enable shared memory multithreading. Huge deal, especially if you can pass these shared structs to something like a web worker. So you have multi-threads, like actual two threads going at once that are accessing the same memory without having to pass messages between them. This will unlock so much power in the concurrency stuff. Things like compilers written in JavaScript can benefit a ton from this. Things like web servers trying to run things in parallel can benefit a ton from this. That crazy SSR framework I built, that hopefully the video for that's coming out soon. Sorry for the delays on that one. That would benefit a ton from this. There's also mutex and conditions, which are higher level abstractions for synchronizing access to shared memory. This will be fun as well. Mutex and condition, oh boy. And also, of course, the unsafe block, which is a syntactic guardrail to lexically scope where racy access to shared structs are allowed. So if you're accessing things in the struct in a way that could potentially cause race conditions, you have to wrap it in the unsafe call. The proposal is intended to be minimal, but still useful by itself without follow-up proposals. The motivations are as follows. Enable new high-performance applications to be written in JS and on the web by unlocking shared memory multi-threading, as well as giving developers access to classes that favor a high-performance ceiling and statically analyzable over flexibility. Very exciting stuff. This is the least flexible proposal I've ever seen in JS, where we can't just do whatever we want. We have to follow rules for the first time because we're thinking about memory for the first time. Thinking about memory in JavaScript is not common, but it's cool to see a proposal that is encouraging us to do that. Like other shared memory features in JS, it is high in expressive power and high in difficulty to use correctly. The proposal is both intended as an incremental step towards higher level, easier to use, like data race free by construction parallelism abstractions, as well as an escape hatch for expert programmers who need the expressivity. Expert programmers and also the Primogen, who I'm sure is going to have a lot of fun with this. The two design principles that this proposal follows for shared memory are the following. 1, syntax that looks atomic ought to be atomic. For example, the dot operator on shared structs should only access an existing field and does not tear. And 2, there are no references from shared objects to non-shared objects. The shared and non-shared heaps are conceptually separate, with direct references only going one way. Interesting. If you, like me, are trying to understand tearing, the best way to get it is if something is trying to read memory. Like let's say it's trying to read a person's name, and at the same time, another thread updates that memory to something else. Then you get a tear, which is the state the thing thought it was getting changed halfway through. So the state it got has torn. Think of it like if you're in the gaming world, like vertical tearing, where if you get a new frame before the frame has updated painting on your monitor, you end up with 2 frames that are misaligned on your display. So let's dive into the actual things being proposed here. First off, we have structs, which by default are not shared. An unshared struct is a refinement on the JavaScript class. They are declarative, like classes, but layout of struct instances are fixed. They have the following properties. They're created with integrity level sealed. In other words, they have a fixed layout. Specifically, they cannot be extended with new properties. The value in their prototype cannot change. Every syntactically declared field is writable, enumerable, and non-configurable. Very interesting that they can all be written and enumerated and not configured. Like all the fields in a struct are locked in. It's kind of crazy classes didn't work this way before, but JavaScript, you know? I also love that you can't extend them. Very exciting. They have one-shot initialization. Once a struct instance is accessible to JS code, all their fields, including those of their superclasses, are already initialized to undefined. So there will never be a state where it's not fully initialized. As soon as it's initialized, all the stuff is there. Huge. The struct does have a usable this value, which is the one-shot initialize instance on entry. As a result, return override is not expressible. Super is still allowed, but not required. Interesting. So what that means is the struct can have a constructor function that can call this dot in order to make something when you're constructing it. They can only extend other structs. The struct constructor itself is also sealed, and struct methods are non-generic. This value must be an instance of the struct or of a subclass. Okay, they still can have methods. Interesting. I want some examples. So here we have a struct box where we set this dot x to be the value you pass in. Let box is new box 0. Box at x is 42. X is declared. Assert throws box.y. Structs are sealed, so you can't update these different fields because it's sealed. So this is just like a really strict object or class. This is cool. If you want to make things that others can't fuck with, huge. I can already see use cases for this for me. You can extend a struct from a struct, which is interesting. And here we've extended it. It's a point, which extends a box, and now it has x and y. We immediately set the y value. We super x, which calls the constructor for box in order to do the thing that we did with x before. Then the return value is discarded, so it doesn't matter. You can't override anything by returning different stuff here. We then have a distance function, which returns math.square root of other.x, Where does other come from? Oh, you're passing it in. It's the distance. Yeah. So other's the other point. So you can pass in other, and you're subtracting other's x from this dot x, other y from this dot y, in order to do a distance function. And here we just have y in order to declare that it has that value. P is a new point, fakes a fake point, and then we pass the fake point over, and it can do the point prototype distance call. P.distance, they're non-generic, so you can't call it on the prototype. You have to call P.distance directly. You can't call point.prototype.distance, which is the thing you do with classes, which is disgusting. And they've locked that away, which I think is really good. Shared structs. Shared structs are structs with even more restricted behavior, so as to make them amenable to be shared between different agents. Their fields can be accessed in parallel by multiple agents. Shared structs, in addition to the properties listed for structs above, have the following additional properties. They can only extend other shared structs. They have a null prototype, or they cannot contain instance methods or instance private names. Their instance can be communicated to other agents without copying. Their fields can only reference primitives or other shared structs, so they cannot point to unshared values. So you can't point it at an object that is accessible externally. It has to be either a struct or a primitive value directly. They also can't be frozen, which is interesting, but makes sense that they would change the shape of the thing, which must be immutable to be amenable for sharing. So here we have a shared struct, new shared box, another new shared box. We have the unsafe, where we're allowed to do things. A shared box.x equals object. So shared box.x is 42. That's fine because it's declared in the right-hand side. This value is a primitive. Here it's fine because this is also a shared struct. But this is not fine because empty object is not a shared struct, so that will throw even in the unsafe wrapper. There's also a reflect helper that you can call to see if something can be shared. And this will assert that shared box 2 can be shared and that empty object cannot be shared. The reason that this is so beneficial is right now, when you spin up a worker in JS, so you're running 2 threads of JavaScript at the same time, they cannot share values between the two. So if you want to pass an object to a worker, it cannot update the object without sending it back to you. And all of that passing back and forth, copying of values, makes the benefits of workers significantly less in terms of performance. You have to eat a ton of memory in order to share things between these instances. The only thing you have is shared array buffer, which, cool, it's fine that you can share a buffer, but that's not like syntactically viable. It's just a way to like dump bytes back and forth. This allows you to share actual objects without having to instantiate them in both places, where when you transform it in one place, it affects the other. This is proper memory sharing with multi-threading, where you can have different objects effectively that 2 threads or more can work on at the same time. That's easy to get wrong. There will be plenty of bad code written with this, I'm sure. But the benefit of well-written things like frameworks and compilers can now multi-thread without just blowing up memory and without having to copy things constantly. Huge, huge potential win. That is so cool. This is what I was looking for. I'm happy they put this in here. And they show the worker code where we have shared box is e.data.sharedbox, and we have this unsafe sharedbox.x equals worker, which is okay because RHS is a primitive, and we can log what that value is. The above program is permitted to print out any interleaving main worker, worker worker, or worker main. That makes sense because in this code, sharedbox.x is main, and it will log that. Here, it's going to log worker, but it could log in any of these orders because it's unsafe. And you know that going in because we're assigning and logging in both the worker and here, but we're referencing the same shared memory instance. That means that by the time this gets set to main, this might get set to worker before we get to the log, and now they're both going to log the same thing. Fire, then these both fire. But the order is not known, and that's why these things are unsafe, because you can't guarantee that this code will always execute in the same order, even though there is no event loop like putting things at the end of the queue. Previously, when you had these weird like orders being different, it was because async was called. It would bump things to the end of the queue, and the order of the queue is what would determine the order things happened. Now, there is no queuing happening. It's just unsafe because you called it unsafe and you're doing things that are unsafe. It's a skill issue, but the fact that JS is allowing these skill issues now in order to make really optimal code is super exciting. And you can see why something like an object that is tracking all of the files for a compiler could use this to not have to re-instantiate all of those things in memory. You can just distribute that across a whole bunch of workers to do the work, and they're all referencing the same thing. That's really powerful if you're good at making sure things are used correctly. They also have shared arrays, which is very interesting. They're fixed length arrays that may be shared across agents. Fixed length says a lot, but specifically that means this can be optimized really well at an engine level. And I'm sure Jared from Bun is looking at this and drooling. They are a special case of shared structs. There's no special syntax for them. They have a read-only length property. That's cool. So you have this assert that shared array length is 100 because we set it to 100. It can't be anything else. And assert here that since we instantiated it, they're all initialized to undefined by default. We didn't have the worker that we spun up. We post a message to it. We set 0 to main. And then in here, we set 0 to worker. And we do the same thing with the log. So we're going to have the same potential outcomes because, again, it is unsafe. It's kind of cool. They're showing the examples of how this is wrong, so to speak, because they want you to know this is unsafe for a reason. But it also allows for so much power. This should be scary to most people, but this should be very exciting to people working on compilers, people working on really performant tools in the browser, people working on crazy 3D stuff. This, if you've never used a worker in JS before, if you've never declared a worker with a different JS file and posted messages to it, this probably won't benefit you at all. But to the rest of the chaotic dev world that does these things, which I am just barely dipping my toes into, this is very exciting. I am excited to play with this. So an important detail with the memory model is that a given read can never tear from a shared struct, regardless of the order that things are happening, because the read will only see one of the writes that happened, and it will not read the multiple, or like if you write twice during a read, it's only going to read the first thing that was written. It's not going to read different things during that one read. So if we, like the thing that we would never happen, if we go back to this example, is you would never get marker, like MA, and then it transitions over to be the other value. Like you'll never get this to output marker. It's going to output one of the values that was written, even if another one is written as you're reading it. That's a little bit of safety I was not expecting. So it's cool they implemented that. I'm not smart enough to understand what any of these words mean. So if somebody is, feel free to make a better video because I will definitely watch and plug that. In order to write thread safe code, there are more pieces necessary, and they propose those here with mutex and condition, all under atomics. Atomics.mutex is a non-recursive mutex. It's a shared struct with no fields. It's used via static methods. If the per realm prototype becomes part of the proposal, the static methods will become prototype methods. Cool. So here we have a lock helper, and the lock keeps track of if something's unlocked or not. So we can look at the example here. Unlock token, get locked, unlock. Cool. Let's see the actual use of it. So we have this Microsoft SharePoint example. Funny, that's actually a hilarious name because it's a point that's shared. And Microsoft has a tool called SharePoint. That's a clever joke. Props to the author for making that one. That's hilarious. So it points a new Microsoft SharePoint, point.mutex, new atomics.mutex, worker.postmessage, unsafe, using lock equals atomics.mutex.lock, point.mutex, point X is main, point Y is main. Then this other using lock, atomic mutex lock, console log, those values. Assume this agent can block. And here we have the same deal using lock equals atomic mutex lock, point X is worker, point Y is worker. Clerk multi-threaded programs are difficult to write because races are subtle and difficult to reason about. Is that Rust's excuse for making it so hard? Or is that Go's excuse for making it so bad? To decrease the likelihood of incorrect programs, access to shared structs are only allowed when lexically contained within an unsafe block. Note that shared array buffer access remains allowed in all contexts for backwards compatibility. The unsafe keyword is a clear signal of intent that a developer is choosing to work with shared memory multi-threaded code. Presence of an unsafe block is an indication to code reviewers that special care must be taken during review. I love this, by the way. It's so important that when you do things like this, it is clear in code review that something is happening. And a lot of tools that I've been losing interest in are because they don't provide enough clarity in code review about what actually changed. This is really cool. I like that they're thinking through code review and how these code bases are maintained over time. It also acts as a syntactic marker that future tools like linters, typeshifters, etc. could use to identify data races. An unsafe block is otherwise treated it the same as a normal block. Its only distinction is that it explicitly labels the code within the block as potentially containing non-thread safe code, like in this case, unsafe code. The general expectation is that any thread safety concerns should be addressed by the developer as control flow exits the unsafe block. For example, you can utilize using to synchronize access to a shared struct via a lock. This should have code block wrap on it for sure. But here we see unsafe code, and we have this increment function that requires you to be locked before you can increment the value to make it safe. Even though we can't increment it here, we can when we call the mutex lock. Good stuff. I mean, you can here as well, which is nice. The one thing people are probably going to be tripped up by is you can't even read shared memory unless you're in an unsafe block. So you can't do anything with the shared struct counter's value unless you are living inside of the unsafe, which makes consuming these things harder. So my guess is how this will be used by libraries is these shared structs are going to be implemented in the library and values will be exposed in more traditional methods. That's my guess. The unsafe keyword is a syntactic marker that applies to lexically scoped reads and writes of the fields of a shared struct instance. Within an unsafe block, any lexically scoped accesses are permitted, even if they are nested within another function declared in the same block. Interesting. So that's actually really cool. So we have this function that takes counter. Oh, I know, it doesn't carry over to invocation of functions declared outside of the unsafe. So we have this function, even though we're calling it inside of the unsafe boundary here, it will still error because the code is defined outside of the unsafe call. Very interesting. That actually, again, helps a ton with code review, because if you were to go change this function and not realize it ran inside of unsafe, that would kill you. Now you have to define the function inside of the unsafe scope. Weird, but good. I like this. As unsafe already indicates a transition boundary between thread safe and unsafe code, there's no need to declare all calling code unsafe, as you might need to do for async and await. Interesting. It's painting the same way async and await do, where once one thing has to await, everything up does too. Unsafe does not mean everything above it or even everything below it has to also be unsafe. The unsafe keyword itself does not entail any implicit sync or coordination, as that would be in opposition to our performance goals. That is actually really cool that you can do this all synchronously as far as JS is concerned. Instead, the onus is on devs to be cognizant of thread safety concerns that they define inside of unsafe blocks. As such, a developer can choose the coordination mechanisms that best suit the needs of their application, be that a mutex, a lock-free concurrent DQ, or other crazy things. This is going to be fun. This is going to be real fun. Apparently, they're also planning on async locking and waiting for these things, and WASM garbage collection interoperability. So if you're using garbage collection with WASM, then you'd be able to have these clean up or not properly. Very exciting stuff. They also don't care about the type system for it. The immutability side, they're not exploring. Binary data overlay views is too many words that I don't understand fully. This is going to be fun. Hope you guys are excited as I am about this proposal. I know it's not for everyone to write, but it is for everyone to have faster stuff. And who doesn't love faster stuff? If you want to hear about all the other cool things coming from these JS proposals, keep an eye on the channel because there's a lot of stuff that happened in this last meeting. Until next time, peace nerds.